Alright, so we got our next portfolio problem here. It states that on the start of 2014, we bought a straddle on a stock with an exercise price of 50. And just got to remember that a straddle is a combination of being long on call and long put on this with the same exercise price. And the expiration date is at the end of 2015, so our time is just going to be 1 year. And the continuously compounded risk-free rate was 3%. And then it says that the price of the call when purchased was 4 and the price of the put was 6, and that the straddle was held to maturity and the position resulted in a loss. What can we deduce about the price of the stock at this expiration date? So we kind of have to know what a straddle looks like to kind of to understand this problem. I got it graphed out here. It's just a V sort of. And what we got to do here is figure out at what point is the stock, if it resulted in a loss, it's going to be in the zeros, below zero down here. So we got to figure out where the break-even points are to know where the stock's going to, what about the price range was. It was going to be in between these 2 points. So we're just going to solve it out here to figure that out. So the cost on the long call was 4. Oops. 4. And the cost on the long put was 6. So when our SFT is less than 50, our payoff is 0. And when our SFT is greater than 50, our payoff is going to be SFT minus 50. And then for the long put, it would be, our payoff is going to be 50 minus SFT. And then if the stock was greater than 50, it would be 0. So just remember that, again, for figuring out the payoffs, that for a call option, our payoff is max of 0 SFT minus K. And for the put option, it's max of 0 K minus SFT. So in this case, for the long call, if our payoff is less than 50, our strike price was 50, so we'd get a number of less than 0, so it maxes. So we're just going to default to the 0, and then if it's greater than 50, well, it'll be above 0. So whatever the stock price is how we do it, is what our payoff will be, and then vice versa for here for the long put. So when we add these up together, I'm just going to put a little bar here. We get that our total cost is 10, and that the total payoff when the stock is below 50 is just going to be 50 minus SFT, and when it's above 50, it's going to be SFT minus 50. Okay, so we just got to figure out what the future value of this 10 cost is going to be when it's continuously compounded for a year. So it's going to be 10e to the power of RT. So t is just 1, so that makes it really easy. It's just 0.03, which gives us 10.30. And we need to subtract that out to our payoffs to get our profit. So minus 10.3. Minus 10.3. So then we get 39.7 minus S of t for our profit if the stock was less than 50. And then if it's greater than 50, we get S of t minus 60.3. So to understand what our break-even points are going to be, we're just going to set these two equations equal to 0. So we have 39.7 minus S of t is equal to 0. we find that to break even, the stock would equal 39.7. And likewise on this side, S of t minus 60.3 equals 0. So just to solve that out, we get S of t is equal to 60.3. So we know that our two break-even points are at $39.07 and $60.03. So if the straddle resulted in a loss, we understand that the stock price was in between these 2 points.